Hello, people of the internet. Hello, internet people. Hello there. That's dumb. I can't steal that because it's not mine. Hi. So I was talking to my brother a little while ago, and he was telling me his girlfriend isn't a big fan of cutting food. She's concerned about cutting herself, right? So I thought I could probably design something that would make that easier for her and help with the anxiety of prepping food, specifically about the knives, because she doesn't really have a problem with the... So I thought maybe I could design something that would sort of help ease that fear, because obviously she still needs to be able to cut her food. So of course, the first thing that popped into my head was some sort of self-actuated knife. I mean, if you're worried about cutting yourself on a knife, it stands to reason that if you make that knife sentient, it should alleviate all those fears, because now you don't have to worry about controlling it. That would be great. Unfortunately, I'm not a great software engineer or computer engineer or anything like that, and I'm definitely not smart enough to be making an artificially intelligent knife. But I can still make something that is more mechatronics based and will essentially cut whatever you point it at. The Not a Scary Knifeinator, TM. So the main components we have here are the knife, of course, because it wouldn't be an automated knife without a knife, obviously. Then back here, we actually have this servo. It's probably a little hard to see. It's in there, but it essentially will actuate the knife up and down. We also have this Arduino Nano right here. It's soldered onto this little, very simple proto circuit here. It just makes the wiring easier. That's the only reason I did that. The Arduino is waiting for a signal from the button. And when it receives that signal, it's going to basically talk to the servo and tell it to swing through whatever range I set, I think is 180 degrees. The servo can go 180 degrees full swing, but just due to the mechanical design, it bottoms out at the top. So I had to adjust that range. So everything else other than the knife and the electrical components were just completely printed out of PLA. So this whole thing was designed around one of my favorite mechanical mechanisms known as a 4-bar. The 4-bar mechanism gets its name after being comprised of, well, 4 bars. Get it? Because it's like there's 1, 2, 3, 4. There's 4 links in the, never mind. Moving on, all the pivots are made out of M3 screws. Every other screw on this is actually an M3 screw, mostly because that's just all I had lying around. I have a whole box of these M3s. So I figured, why not? Let's just use a bunch of those. Unfortunately, screws make terrible pivots because they're made to screw in and screw out. So as you work the actual pivots themselves, as it's swinging up and down, it's working its way in and out of the actual links. And eventually the screw will back itself out, which is not what you want. So in order to get around the whole screws backing out issue, I ended up just using what are essentially 3D printed bushings. And they basically just prevent the threads on the screw from actually interacting with the working surfaces. So that as you work the pivot, they basically just don't back out. That's basically how that's how I solved it. It wasn't that hard. I mean, there were some issues with those because I have like these built-in washers and they have a tendency to shear off, but that's another thing. One of my favorite things about 4-bar mechanisms, and then actually designing 4-bar mechanisms in general, is the fact that you can take advantage of a graphical design method, which basically allows you to pick a starting position and essentially an ending position of one of your links. In this case, it was the link that holds the knife. And by doing that, you sort of constrain where these other 2 pivots have to go, but there's sort of a range of places these pivots can go, and you sort of put them where you need them. But basically, it allowed me to pick this path that I wanted the knife blade to travel in, and it essentially told me areas where these pivots here would need to be in order to make that path happen. So I was able to design the rest of this around that information. And I think it's just a really powerful design tool. Personally, I like it a lot better than the analytical method, just because if I don't have to do math, I'm not doing math. And also it's just really cool to see this path. You can like literally draw it and you'll see the path that it takes and you see the points. I don't know. To me, it's really cool. It's probably dumb, but I think it's really cool. There are a few things about actually using the graphical design method you sort of have to keep an eye out for, but it's a little beyond the scope of the video, and it can be sort of difficult to explain all the detail using this already completed, totally perfect, not a scary knifeinator TM. If you're interested, leave a comment and I'll try to make another video sort of going more in depth on how to actually design using this method, because it is really cool and it's a very useful tool for little projects like this. So now that the design is all done, I've got the electrical, I got everything wired up. I designed it to just work on just a standard wall wart basically. So I'm gonna grab my brother and we're gonna run to the kitchen and try it out on some vegetables and fruits and whatever we can find in the kitchen. I don't know if we've stocked the fridge in a while, so we'll have to see. Okay, we're in the kitchen now. We've got all the supplies. We're gonna do some test cutting. I got my brother here. Supposed to get over here, Nicholas. Yeah, now give me the shot. Just a banana, an apple, and some cheese, because that'll be good. And we're gonna try cutting it and maybe make a nice salad, assuming everything goes well. And bananas definitely go in salads. We're gonna try and use the not a scary knifeinator TM and do some cutting. Alright, there we go. We've got a beautiful garden salad. We've got our apple slices, a little bit of banana. Obviously we got our greens there, and a nice light sprinkling of cheese. Here you go. You gonna try it first?
I'm gonna let you have that on here.
Alright, I'll get a nice little piece of apple in there. It's not bad.
Très elegant.
Très elegant.
It's light, nutty, with a hint of chestnut. You can taste it in there.
It's definitely fruity, and there's a little bit of like a tropical flavor.
Yeah.
Oh, that's the worst part. Oh yeah. It's definitely a success. It's
still totally
only slightly warm. Works great.
I would buy it.
As you can see, totally works. No problems. If you have any ideas for other designs I could do, definitely leave a comment and let me know. Yeah, I could always use more projects. I don't know how to end the video. I've never done this before. Okay, bye.